We're going to need to use these identities again while we're working through some of these proofs. So reminder, even and odd identities, if you have negative angles for sine, cosecant, tangent, or cotangent, you can just pull the negative out front. And if you have a negative angle for cosine or secant, you can just ignore that it even exists in the first place, and that's it. Okay, so we're going to use that, add that to your identity list while we work through these proofs. All right, prove that secant of negative theta minus sine of negative theta times tangent of negative theta equals or simplifies to cosine of just normal theta, not negative anymore. Okay, so there's a lot of negatives going on in here. So let's first deal with that and get rid of these negatives. There's too many. So we're going to use our even and odd properties here to get rid of our negatives. Okay, so reminder, cosine and secant are the two where you would just ignore the negative altogether. The other four, you need to pull the negative in front of the trig function. So for secant, if I use my even and odd property here, I can ignore that negative sign even exists. Minus, this is going to become a negative sine theta. And this is going to become a negative tangent theta. And reminder, we only work with the left-hand side and simplify it to get to our cosine. So minus negative sine theta times negative tangent theta. Okay, we still have a ton of negatives going on here, but they're all being multiplied here. So I can either say minus negative, this is a double negative, which is going to make it a positive, or I can say negative sine times negative tangent. This is a double negative again, that's going to make it positive. So either way, we're going to end up with 2 out of these 3 negatives here are going to cancel each other out. That could be positive, but I still have an overall times negative here to make it negative. Either way, I'm going to end up with this. And that's because I can either multiply these 2 negatives together to make them a positive, and I still have my minus sign, or minus a negative means this is adding, but I'm adding sine times negative tangent, which will make this overall a negative. So I'm adding a negative sine tangent. I guess let's just say we're going to simplify here because we simplified our double negatives, or you can say something about double negative if you want to. Just use some kind of word to describe what you just did. So double negatives is probably more helpful or clearer, but that's what we did. We got rid of all our double negatives. All right, but this still doesn't help me get to cosine at all yet. So my favorite trick, I know I use it every single time, probably early on, is let's convert to sines and cosines. There's too much going on here. We have 1, 2, 3 different trig functions plus a fourth one we're trying to get to. Let's narrow that down and convert it to sines and cosines. So secant is 1 over cosine. Sine is already written as a sine, and tangent is sine over cosine. And since this is sine times tangent, I can just think of this as one long fraction. All right, well, now I'm adding fractions together. So you can either say, can I simplify this one? Can I simplify this one? And try and break it down further? I can't. So your other option is, since I'm adding fractions, let's try and get a common denominator. We already have a common denominator. Perfect. So I don't need to get a common denominator, but I can write as one fraction to see if anything jumps out at me. So I have my cosine in the bottom, and I have a 1 minus sine times sine, or 1 minus sine squared theta. Always, always, always look for identities, especially the Pythagorean one. Do you see 1 and sine squareds and cosine squareds mixed together? See if you can get the Pythagorean identity to look like what you have in your problem. Well, I can. If I subtract my sine over to the other side, my sine squared over to the other side, look, this is what's in my problem. Woohoo! So I can replace it with this left-hand side. So I used the rearranged Pythagorean identity, and I got this top part is equal to cosine squared theta. That made my problem so much nicer because now I have a cosine squared over cosine. Cosine squared is the same thing as cosine times cosine. You don't really have to write this. I'm just trying to make it super clear what's happening. And one of my cosines will cancel with the one in the bottom, and I'm left with just a cosine theta on top, which was my goal. So, woohoo, we're done. For Alex, they will use even and odd, but for pretty much everything else, they're just going to say algebra. They will convert this using two steps. This will be the quotient step, and this will be the reciprocal step, because those are the identities they use it. I can't spell. They probably will just call this algebra. They will call this Pythagorean identity. They won't say rearranged. And then when you cancel, that'll be algebra. All right, let's do one more example. This one is super intense because it pulls upon a ton of stuff. We can do it. Just like last time, there's a lot of negatives going on. So let's first deal with our even and odd identities to get rid of those negatives. So even, odd identity. Cosine and secant are the two where the negative is irrelevant. Who cares what the negative is? We can just pretend it doesn't exist, which is pretty convenient for this example. All right, next, there are a couple options of what you can do. I personally like to convert everything to sines and cosines because it just is cleaner that way to me, although it may not look cleaner at first. So let's convert. Secant is 1 over cosine. All right, this looks worse, but I promise you it won't be. I have a fraction down here that I'm trying to add, so let's get a common denominator and deal with adding those two together. So if I want to get a common denominator, that means I need to put a cosine down here. If you put a cosine on the bottom, you have to put a cosine on top also. So my numerator is as is, we're not messing with it right now. But in the bottom, I have 1 over cosine minus cosine over cosine. And now I can write the bottom, the denominator, as 1 fraction. Which still you may be thinking, this does not look any nicer. But if I write this bottom piece as 1 fraction, I'll have 1 minus cosine theta over cosine theta. And you may already see what's going to happen here. I personally have to keep change flip every single time because I cancel things out when it's not supposed to cancel. Like, I just do bad mistakes. So I am going to personally write the top, keep the top, change your division fraction bar to multiplying, and flip. So you can write it as division and then keep change flip, which I guess is probably what I should do if we want to be super clear with our proof. So if I write it as division, I have the top divided by that bottom fraction. I just put parentheses there to make it super clear. And now I can keep change flip. So keep the top as is, change the division to multiplying, and flip the second fraction. Now it's all, this is a multiplying sign, so I can just think of this as one long fraction. And I can put in my parentheses if it'll help me clarify what's going on. And when you see that, you might realize I have a 1 minus cosine theta on top and on bottom, so I can cancel those out. And I'm just left with a cosine theta. So we made it messier, way messier before we got to our final answer, which is nice and pretty. You know, it's always darkest before dawn. That's what happened here. But we got there. You just have to keep trying some things, follow through your hints, and see what happens. But we did it.